To finish up our introduction to functions, we have two more examples. The first one says that a few years ago, a cell phone company charged $30 per month for the first 600 minutes and 10 cents per minute thereafter. So what is the charge for 750 minutes? And then we'll write an equation for the cost function for any number of minutes. It'll help us, it'll warm us up if we can figure this out first. 750 minutes. How much does that cost? Well, it's certainly going to cost $30 because no matter what, you have to pay $30. And then, how much extra do we pay for the first 600 minutes? Nothing. We only pay 10 cents for every minute after 600. So how many overage minutes do we have here if we're allowed 600? We'd have 150. So plus 150 minutes times 0.15. Okay, so I'll let you plug that into the calculator and figure out what that is. This is for 750 minutes, but using this knowledge, think about where the 150 number came from, because we want the function c of t, the cost function, where t is the number of minutes. So if I plug in 750, I want to get out this number here, whatever that number was. If I plug in a 0 for t, the number of minutes, I want to come up with a 30. So I know I have to pay 30 plus 0.15 times something. How did I get this number 150? Well, the 750 minutes kind of really corresponds to our t. T is 750, and then how did I get 150? I subtracted 600. So t minus 600 would give me this number here. Now we're not completely through here, but this will work. For example, if t is a 600, what is the cost? Well, it should be $30 a minute because you get 600 minutes free. So we get $30 plus 0.15 times 600 minus 600 is 0. So we would get $30 as we expect. But this doesn't take care of the situation where t is less than 600. So we're going to have what's called a stepwise function here. If t is at least 600, this is what we use to compute it. If t, I'll put else here, which means t is less than 600, it's just 30. So this is a piecewise function, and this is the correct cost function. If t is less than 600, the cost is $30 for that month. If t is greater than or equal to 600, we come and plug it in here. And the t minus 600 will give us how many overage minutes that we used. Those cost 15 cents per minute. And then you add on the $30. So this one was a little bit tougher, but take a look at that. I think it'll be clear after you read it a few times. All right, our last example. This problem says, under normal conditions, a formula, a function, that estimates the stopping distance d of a car in feet, the number of feet required to stop, is this, where v is the velocity of the car in miles per hour. So let's find the stopping distance d of a car traveling 30 miles an hour. That means v is 30. So just plug it in. We get d equals 1.1 times v, which is 30, plus 0.055 times v squared, which is 30 squared. Well, if you plug that into a calculator, you would get 82.5 feet. So that tells you if the car is driving 30 miles an hour and you stop in as fast as you can, it's going to take 82 feet and a half to stop till you get down to a speed or a velocity of 0. Now let's find the stopping distance of one more speed, 60 miles per hour. So some of you might already think you know the answer. Well, 30 miles an hour took 82 feet to stop, 82 and a half feet. What do you think the stopping distance will be for 60 miles per hour? If you simply double this number, you are incorrect. You're going to be way too low. The faster you go, the more you increase the speed, the number of feet required to stop increases at a greater rate. So let's just observe this. D equals 1.1 times 60 plus 0.055 times 60 squared. If you plug that into the calculator, you get 264 feet. Over 3 times the distance. Even though the speed was only doubled, going from 30 to 60, the number of feet required to stop, look at that, went up over 3 times. So that's a warning. When you go too fast, the number of feet required to stop increases greatly. 264 feet for that one.